0-1 knapsack problem is a very common and popular problem in algorithm design technique and also in data structure and algorithm subjects. 0-1 knapsack problem. First, let us understand how the problem statement is. A thief is trying to rob a store and wants to take most valuable load that he can be carried in a knapsack capable of carrying at most W pounds. So knapsack is a kind of a bag. That bag has at most, the thief can carry at most, total capacity of the bag is W, let's say W pounds or W kg. That is at most he can carry in a bag. And let's say he has gone into a bank to rob the golds. Okay, so gold items. So these gold items is a special kind of a gold item which cannot be, let's say, breakable. You cannot break the gold. So small gold items are there. Each gold items, let's say, in terms of grams of kg, and let's say kg, okay, or grams. So, and the knapsack also, let's say W kg, and golds are in terms of grams. So the problem statement says that thief has to carry, let's say, n number of such kind of items are there. So the problem statement says that n number means, let's say, 10 items or 3 items are there. So if there are 3 items or 3 gold items are there, thief can either pick first item or he can leave the item. He can either pick second item or he cannot pick the second item. He either pick the third item or he will leave the third item. That means he either picks it. If he picks, it is 1. If he doesn't picks and ignore it, then it will be 0. That's why this problem statement says is 0-1 knapsack problem. So this problem statement is important. So that means thief can either pick the gold item or he can leave it. That is what 0 or 1 knapsack problem. If he doesn't pick, then it is 0. If he picks, it is 1. He cannot break the item. That's why it is called 0 and 1. Full item he has to take. If there are 3 items, either item 1 he has to pick, and then item 2 or item 3 if the chances are there, depending on the capacity of the knapsack bag that he has carried. So by this process, if it is the case, then how much maximum weight the thief can take from the bank, I mean the gold items. So he can pick randomly because it's a greedy method. Let's first discuss the greedy method, how greedy method will perform. So if it is a greedy method, he can choose any gold item. Item 1 he can choose, or he can leave item 1. Item 2 he can choose, or he can leave item 1, 2, and finally item 3 also he can choose, or he can leave item 3. So you can see here, item 1 is, let's say, 10 pound or 10 kg, whatever you want to say, and the cost of the item is $60. Item 2 is 20 pound and the cost of the item is $100. Item 3 is 30 pound and the cost of the item is $120. And he has a knapsack whose total capacity is, let's say, 50 pound. Okay, 50 pound. So that means maximally he can carry in the knapsack total 50 pounds of gold items. So this is the problem. So now, if it is a greedy method, if it is 0-1 knapsack and greedy method, then what he can do, he can either pick item 1, let him pick, so item 1 has come, or he can say he can pick first item 2. Okay, he can pick first item 2. So item 2 is 20 here. I hope you are able to see it. So item 2, this is item 2. Item 2 is 20, that means he is picking this one, and then he is picking item 3, which is of 30 gram, let's say, and let's say 30 gram, and total knapsack capacity is, let's say, 50 gram. Okay, so 20 plus 30, total is $220 of gold item he has captured in the bag or in the knapsack. If he chooses item 2 and item 3, but it is a greedy method, he might also can choose first item. He might also choose the first item. So let's say he is picking first item. So first item is 10 gram and second item is 20 gram. So if it is 10 and 20, which is 30, that means remaining 20 gram he cannot take from item 3, because item 3 is 30 gram. It's a 0 or 1 knapsack. That means If he wants to take item 3, he has to take fully. That means 30 gram will come together, but the size of the knapsack remains 20 gram only. So he cannot put it here, right? He cannot put it here. So this much of amount of knapsack will be wasted. This amount of weight will be wasted in the knapsack. So in this case, it is totally 20 gram is costing $100, 10 gram is costing $60, total $160. This is the second case. In the third case, let's say he is picking. In the third case, he is picking item 1 and item 3. That means item 1 is 10 gram and item 3 is 30 gram. So which is totally 40 gram, and the total cost is 180 gram, let's say. Okay, or 180 pound. So here it is 30 plus 10, 40. So remaining this 10 pound or 10 gram, that is not possible to fix with 20 second item, right? Because he has picked this 10 and he has picked this 30. 10 plus 30, 40. Remaining portion cannot be filled with this one. It's not possible. So this is also a bad choice of greedy method. So this total cost is $180. So this is total $160 and this is total $220. So 0-1 knapsack wise, if he goes total maximum $220 of worth of gold he can choose. But then it is not optimal, considering that it is a 0-1 knapsack problem. Now if we allow this problem to be a fractional knapsack, okay, so fractional knapsack, what will happen is that will allow to break the gold item. Okay, you can break it. So first, for that what you have to do is we have to first calculate each item, each pound or each gram cost how much for each item. So first item, each gram cost is, in this case you can see here it is 10, 60, so each is $6. So here item 1, per pound cost or per gram cost is $6, per gram or per pound cost is $5. Here item 3, per gram or per pound cost is $4. So this is maximum, this is maximum, the first one is the maximum, So in this case, what he can do, he can have first, because it is a costlier, this is $6, this is $6, this is $5, and this is $4. Okay, so it is the most costly, the item 1. So first is fill this thing as a full 10 pound he has taken in the knapsack. Remaining one is this one, 20 pound, which cost $5 each, and he take fully $5. That means he take fully this 20 gram, 10 plus 20, 30. Remaining 20 gram or 20 pound, what he can do, he can take the fraction of it, but it is of third item is the 30 pound. So here only 20 plus 1, 10, 30 has been done. Remaining 20, he cannot take 30 here, but because it's no longer 0-1 knapsack problem, it is, we allowed the gold to be broken. That means fraction of the golds are allowed now. So what he will do, because per pound gold for the item 3 is costing around $4. So remaining 20 he will fill $4 each. 20 into 4, $80 he will fill it. So 80 plus 100 plus 160, which is $240. But in the 0-1 knapsack problem, $220 is the maximum. So this concept is called fractional knapsack. Okay, this concept is called fractional knapsack. This concept is called fractional knapsack. Okay, this is fractional knapsack. You see here, this is called fractional knapsack. When we are not considering 0-1, we are allowing this fraction part to be, included, fraction part of the gold to be included in the knapsack, call it fractional knapsack. That means for greedy method, fractional knapsack is the best problem to be implemented. Or in other way, 0-1 knapsack, the greedy method is not suitable for 0-1 knapsack. On the contrary, fractional knapsack, for fractional knapsack, greedy method is a perfect choice. So I hope you understood this difference between fractional knapsack and 0-1 knapsack.